All right. So when it comes to rounding, some rounding rules to keep in mind. Okay. Now, this is also outlined in your packet, your dosage calc packet. It goes over the rounding rules. But so when we're dealing with drops, okay, when you have drops, you're going to always round to a whole number. Okay, so you don't round, you can't have like a fraction of a drop. So when you're doing like drop rate and stuff like that. So as an example, if I were to, let's say I had 49.99 drops, you would round that to 50 drops. Okay. Now that shouldn't be an issue on the actual test, but if that does come up, just know that it's the nearest whole drop when you deal with drops. For numbers greater than 1, okay, like 1.25, you would round that number to the nearest 10th, which would be 1.3. For numbers less than 1, such as 0.125, you would round that number to the nearest 100th. So 0.13 would be how you would answer, or how you would round that question. Typically you round, like anytime you go from like pounds to kilograms, or if you're going from like ounces to milliliter or teaspoons to milliliter or something like that, you may, those are the only times you round when you're doing those types of conversions. When you're doing basic conversions like milliliters to liters or micrograms to milligrams, you do not round those numbers. Okay, so the rounding rules only apply either at the end of a question where there's actual like medications mentioned, like if you're adding together visceral mepridine, you would round to like 1.2 liters or milliliters or whatever that case may be. But you would not round when you are going and doing basic unit conversions within the same units. Like I said, again, like milligrams to grams or milligrams to micrograms and vice versa. So that's rounding in general. All right. So the first question I believe that was asked is about the Heparin protocol. I'm going to go ahead and post this in the chat if you don't have access to it already. This is my OneDrive folder that has the practice tests. Sometimes if I get a chance, I will add more to it. But I've been saying that now for a number of semesters and I haven't really added much to it. I have something for the 240 class that might be relative to your class. So when that gets posted, you can check on that. It's not in there yet, but it will be there either today or tomorrow. And then I will post the recordings for this on YouTube. And I also posted there in the chat box my link to my YouTube channel so that you can get that. I already have posted the morning sessions, and then I'll have the evening sessions posted. I say morning sessions, we start at noon, so everything's afternoon, evening, so you know what I mean. All right, so the Heparin protocol. So for you guys, this is the first time seeing this, unless you've been on my YouTube channel and watched the various times I've gone over this. But this is what your Heparin protocol looks like. Now, I know this doesn't show up very well when I use my document camera, but obviously when I write, you'll see it just fine with my marker. But this is just to orient you to what the page that we're talking about. And if you need to, you can just pull that up on your or in front of you, or pull it up on your computer. So with the Heparin protocol, there's a whole lot of stuff here that is not essential for solving the Heparin protocol. The first thing is the only questions you're answering are down here where it says answer the following questions. You're going to calculate a bolus. You're going to calculate an IV drip. You're going to recalculate a new bolus and then recalculate a new IV drip. And you're going to get some practice. On the actual test, you'll either get only A and B or only C1, C2. So you won't get all 4 questions, but there will be at least 2 questions to answer to correctly answer the Heparin protocol. But those 2 questions only count as 1 question on your test. So if you happen to miss both, you've only missed one when it comes to missing questions on the test. But once I show you how to do this, you won't miss it. Okay. All right. So it's in the protocol, there's 15 steps. The only steps that are really important for you guys are steps 1, 2, 10, and 12, at least for this particular question. Steps 1 and 2 tell you to, step 1 tells you to convert the patient's weight that's given to you in pounds to kilograms. And then step 2 tells you to what you have, you're available. So you have an IV of 25,000 units heparin in 250 ml half normal saline. And then your bolus dosage strength is 1,000 units per milliliter. So you need those two pieces of information in order to calculate your bolus, in order to calculate your IV drip. Number 10 just repeats what's stated up at the beginning of the question to bolus the patient with heparin 80 units per kilogram, and then start the drip at 18 units per kilogram per hour. So it's restated there. And then after 6 hours, the APTT is taken. In the big practice, it's 43 seconds. So if it was any other time, you would just look at what other time, and then you would apply whatever it says in the box next to it. So step 12 tells you to rebolus and then to do something with the rate, but we'll solve parts A and B first, and then we'll get into the meat of this right now. So, and the other thing is, if you want to practice, just change the patient's weight. So make it your weight, your friend's weight, your mom's weight, your dad's weight, grandpa's weight, somebody else's weight, and then just calculate what you get. And then you can, if you want to double check your answers, you can always send them to me and I will verify that you got the right answer. Or I can even work it out for you on and post a video on YouTube. Just let me know what you want. When you're converting pounds to kilograms, once you get to kilograms, round to the nearest tenth before you do these other calculations. The only reason I'm telling you that is because when I create the key, that's how I do it. Just to give you a heads up. Okay, so we have a 110-pound individual. This is 25. 110 pounds. We need to convert that to kilograms. So that is equivalent to 50 kilograms. So 110 divided by 2.2, 50 kilograms, no rounding required. Then we're going to take, and it says to bolus the patient, and we need to account for the patient's weight because it's a weight-based problem. Patient weighs 50 kilograms. The initial protocol tells us to bolus them with 80 units per kilogram. Now, we're going to do 50 times 80, and we're going to get 4,000 units. Now, once we have 4,000 units, if they had asked us how many units to bolus with them, we'd be done, but they want to know how many milliliters. So in order to find that out, we're going to use our protocol. And the protocol tells us in step 2 of the protocol, bolus dosage strength, 1,000 units per milliliter. So I just want you to know where I'm getting this from. So I don't want units. I do want milliliters. 1,000 units, 1 milliliter. And I'm left with my answer of 4 milliliters is how much I'm going to give as a bolus dose. Part B. So again, the only thing that's going to change for the bolus dose on your test is the patient's weight in kilograms. Okay, that's why I told you to practice it. Just change the kilogram weight, and then you're going to follow the same exact procedure. And then your outcome obviously will be different. So it might be 4 milliliters, it might be 4.2 milliliters, it might be 5 milliliters, whatever it happens to be. Same patient, same weight. We're going to start them on the drip of 18 units per kilogram per hour. Again, I'm just getting that from the protocol and also from the first line of this question number 25 to start them on a drip at 18 units per kilogram per hour. Don't get hung up on the term drip. because I know drip, you want to think of drop rate, but here they're just meaning the infusion rate. In reality, it might actually be a drop rate. So this might actually eventually make its way into drops per hour, but we don't have that listed. So milliliters per hour is what it is. So 50 times 18 is 900 units per hour. Now, if this 900 units per hour looks familiar, that's because questions 22, 23, and 22 and 23 are kind of designed to warm you up to the heparin protocol. So question 22 says you have 1,000 milliliters of IV with heparin, 25,000 units, infusing at 1,000 units per hour, calculate flow rate. And then 23 is similar question, but using insulin, where you have a flow rate of 10 units per hour. Here we have our example of 900 units per hour. And we need to convert our units per hour to milliliters per hour. And we're going to do so by converting units of milliliters. In order to find out what that is, looking at our heparin protocol, the heparin protocol in part 2 says 25,000 units, 250 ml, half normal saline. So I'm going to just plug that in here, 25,000 units, 250 ml. And when I do that, cancel out units, I'm left with milliliters per hour, and I get 9 milliliters per hour. Okay. Now, that is how you would answer A and B on the heparin protocol. This is the bolus. This is the initial drip rate. So the initial bolus, initial drip rate. Now, when we get to part C, it says we took their APTT after 6 hours. It was 43 seconds. And once we look at that, we can see if it's within that range of 43 seconds, there's some new procedures. It says to rebolus. So we're going to do it again. We're going to bolus dose again with 40 units per kilogram. And then we're going to increase the rate by 2 units per kilogram hour. So we have to make some adjustments to our initial protocol. So the questions say to calculate the number of milliliters to prepare. That's for the new bolus. And then to calculate the new infusion rate in milliliters per hour. So step 1, same patient, same weight, but this time instead of 80 units, it's 40 units per kilogram. Eliminate kilograms. We get 2,000 units. We don't want units, we want milliliters. So I'm going to use the same bolus dosage strength of 1,000 units per milliliter. And we get 2 milliliters. Now, if you're looking at this and said like, well, I understand that 40 units is half of 80 units. So if that was 4, then the new one should be 2. You did that right. So I'm not here to tell you not to do that. You did that right. Part 2, I'm going to follow the same procedure, same patient weight. Now it tells me to increase the infusion by 2 units per kilogram per hour. What was our initial? Our initial was 18 units per kilogram per hour. So if I'm increasing that by 2, it becomes 20 units kilogram hour. $50 times 20 gives me 1,000 units per hour. Again, just like question 22 and 23, or is it 23 and 24? Oh yeah, 22 and 23. We're going to make a conversion going from units to milliliters, and I'm going to use the same IV bag to make that conversion. 25,000 units, 250 ml, and then we're going to get 10 milliliters per hour. When I was first doing this particular question and I was figuring out how to answer these questions, I initially said, oh, increase by 2 units. Okay, 9 becomes 11. Okay, but this is milliliters, not units. So you don't increase that number by 2. Notice it only increased by 1, even though we increased the units by 2. So make sure you make your changes here. And if you look at the other protocol or the other steps in the protocol, there are other calibrations. Increase by 4 units. We did the increase by 2, decrease by 2 units, decrease by 3 units. There's different variations that we might do when it comes to depending on what the APTT indicates what we're supposed to do. Okay. So that, my friends, is the heparin protocol. So number 16, you have your to administer dextrose 5% water IV solution or 5% dextrose water IV solution at a rate of 75 milliliters in 25 minutes, and then to calculate the flow rate. And then we see that the flow rate, our drop factor is 15 drops per milliliter. So as a reminder, and hopefully it's a reminder, but if not, it's okay. When we're calculating flow rates, we need 2 pieces of, or when we're calculating drop rates, we need 2 pieces of information. We need the flow rate and we need the drop factor. So number 16, we need the flow rate. We need the drop factor. Those 2 pieces of information gives us the drop rate. Now, the flow rate for this question is 75 milliliters, 25 minutes. The drop factor for this question is 15 drops per milliliter. And then that gives us an answer of 45 drops per minute. And all I did here was I did 75 times 15 divided by 25. Or what you could have done is just did 75 divided by 25, which is 3 times 15 is 45. So there's 2 different ways to kind of set that up. The other thing is you don't need to convert minutes to hours because we're looking for minutes in our final answer. So just leave it as minutes. Okay. And then if you, if this were in hours, you would just convert hours to minutes. You're welcome, Casey. So for question 17, it says your patient has received Solumedrol 200 milligrams IV. It is received from the pharmacy in a 75 milliliter bag of dextrose 5% water to infuse, or 5% dextrose water to infuse over 30 minutes. The drop factor is 10. No other IVs are running. What is the correct drops per minute flow rate? So what did I say in question 17? What pieces of information do I need? I need flow rate and I need the drop factor. So the flow rate they give me is 75 milliliters and 30 minutes. The drop factor they give me is 10. And then we just solve the equation. Now you may be wondering, what do I do with the 200 milligrams? Good question. Doesn't matter. 200 milligrams has nothing to do with flow rate. That just tells us what is in the IV. And when we're talking about flow rates from the math perspective, we don't really care what's in it. We just want to know what to infuse. When you're dealing with your patients, absolutely, you care what is in it. But when we're calculating flow rates, we just care about volume over time times the drop factor. So for this one, 75 divided by 30 comes out to 2.5 times 10 is 25 drops per minute. The other way you could have done this is just 75 times 10, which is 750 divided by 30, and you'll still get the same answer, 25 drops per minute. And then I'm just going to double check because I'm sitting here going, did I answer that question right? I believe I did. So 75 times 10 divided by 30, 25, yes. The analogy I always use for question 17 with that, where it tells you the 200 milligrams sodium medrol. If you're driving on an interstate and you're going 60 miles per hour and, you know, you just want to know how fast you're going, it doesn't really matter what you're in. Are you in a minivan? Are you in an SUV? Are you in an Aston Martin? It doesn't really matter what you're in because you're traveling the same rate of speed. So if the question was, you know, how long will it take us to get there? Kids in the back saying, how long, how long? And if you're 2 hours away, you know that based off of the speed that you're going. So anyways, something to think about. Question 21. And I 100% agree with you. Sometimes it is helpful just to see it and hear it live, just so you can kind of follow along with it as you're trying to figure this stuff out. Let me just find it real quick. Oh, okay, the Pfizer pen question. Okay. So first of all, if you may remember from last semester, the milliliters diluent added is not factored into solving these equations, and there's a specific reason why. This just tells the pharmacy how much deionized water to add to the powder to make these concentrations. Okay, so if I need a weak concentration, medium strength, or the most or the strongest strength, then these are how we would get to those concentrations. So we ignore the milliliters diluent added when we're doing this question. So Pfizer pen, 350,000 units. Okay. I don't want units. I want to know how many milliliters. So I use the strengths that are listed, and it tells me that I have 1 million units per milliliter. So 350,000 divided by 1 million gives me 0.35 milliliters. Yep, you're welcome. Yeah, so and then as a side note, sometimes when you see all these zeros, it could be daunting. Cross out the 4 zeros here, cross out the 4 zeros here, 35 over 100 is how you would solve that. And again, you wouldn't round this to 0.4 because this is a number less than 1. So you keep it to the nearest hundredth. If this was 0.375, then yeah, you would round it to 0.38, but you don't round to the 10th, you round to the 100th in this particular question. So 22 and 23. 22, like I said, is a workup for the Heparin Protocol. So 22 says we have 0.45% normal saline, 1,000 milliliters IV with heparin, 25,000 units. And it's infusing at 1,000 units per hour, but I want to know what that is in milliliters per hour. So I'm going to take, I always start off with 1,000 units per hour times, I want hours, but I don't want units. I want milliliters. I have 1,000 milliliters and I have 25,000 units. So I'm just going to do 1,000 times 1,000 divided by 25,000. Divided by 25,000. And I will get 40 milliliters per hour. I mentioned to the earlier session, I'm going to try and upload some more of these types of practice questions. It'll say like it'll be like the 240 questions. It'll say like 240 additional practice questions, but it will apply it because it's more questions like this. So you guys can do them as well. So this would apply to the 220 and 230, and it'll be in that link that I posted in the chat at the start of the review. And if you need it, you can always email me as well, or just get it from a friend. And it's not in there now. It will be in there either today or tomorrow. Not that any of you wanted more questions to work on, but maybe you do. All right, 23 is, I'm going to follow the same format. So it's 0.9% sodium chloride, 500 milliliters with Humulin R, regular U100 insulin, 500 units of that. And it's infusing at 10 units per hour. I want to know how many milliliters per hour. So 10 units per hour. I don't want units per hour. I want milliliters per hour. So I need to convert units to milliliters. There's 500 units within 500 milliliters. Units cancel, left with milliliters per hour, and I get 10 milliliters per hour. Now this one just happened to work out because we can cross those two out. But if you just want to be on the safe side, 10 times 500 divided by 500, you'll still come up with 10, same as me. And the reason I said earlier that these are to help you warm you up for the heparin protocol, because when you do the heparin drip, you're going from units per hour to milliliters per hour. So these are just warm up questions for that. And then the bolus dose you've also done. The only difference is there's a weight base. There's a weight to be considered, but you're really just putting different key things together that you've done already multiple times throughout all the semesters that you've been doing these drug calc, dosage calc stuff. So 20 is just like the Pfizer pen question. It just doesn't have any drug mentioned. It says that we have the order is 60 milligrams. And then it says to choose the strongest concentration and then calculate the milliliters. So every single one of the concentrations is the same, milligrams per milliliter. So which one is stronger, 20, 10, or 5? And the answer is 20. 20 milligrams per milliliter, that's more milligrams per milliliter than 10 and more than 5. So 20 over 1, and that would give us an answer of 3 milliliters. So that's how much you would administer from the strongest concentration. The other thing, what else did I mention for this question before? The other thing is some of you hate that I'm writing all these things in dimensional analysis. So if you were going to solve it, this is the other way that you would do this. Just so you know that we're all going to get to the same answer. As long as you're getting the same answers consistently, you are doing it right. So you don't have to follow my methods. I find that it's easier for me to give you a visual representation of what you're learning by doing it this way.